Am I audible to one and all? Good evening, everyone. It's a great pleasure for me to introduce our speaker today, Mr. Suyash Bajpai, who is a senior security analyst, a certified ethical hacker by EC Council, and an IoT security expert. He is going to talk about IoT security, so be ready. Over to you, sir. Sir, are you there?
Yes. Thank you, Vanchika. Hello, good evening, all.
Good evening, sir. You're audible.
Okay. Hello, good evening, all. Hope you are well and safe at home. So today I'm talking about the IoT security. So let me know. I'm sharing my screen. Let me know it's visible to you. It's visible, right?
Yes, sir, it's visible.
Okay. So IoT security, and we are talking about the pen testing approach and methodology, and what we are going to cover in this session. And so basically about me, and my name is Vajpayee, as you know, and I'm a senior security analyst by profession, and my expert key areas are like threat intelligence and dark web monitoring, open source intelligence, red teaming, IoT security, robotics, and security research and development. So coming to the IoT, like what is IoT? And the agenda is to cover like what is the IoT and how IoT works, what is the ecosystem of IoT, and what are the approaches and methodology, vulnerabilities, and we are going these cover these topics in the next slides. Okay. So basically, what is IoT? IoT is the network of physical objects. Like if you're talking about IoT, they are combination of the sensors, softwares, and the electronics, and connected via the network connectivity. It can be a Wi-Fi, it can be a network LAN, and connected with the mobile application, which is and the data exchange over the cloud. Okay, so we are talking about like how we are going to protect these IoT devices in the next sessions, and what are the challenges we are facing right now, and what we are going to cover. Okay, so according to the reports, like research reports, into 2030, around 50 billion devices will be connected by a IoT network. Okay, so every device or every sensor or every light, like home that are the like table lights or fans, and they are connected via IoT, and you can use via phone from anywhere in the world. Okay, and the revenue growth will be going to the 1.9 trillion to 7.1 trillion by 2020. It is the previous year data. So we need to understand what is the IoT ecosystem. So if we talk about the IoT working, so there are the devices like you can like there are the meters, and there are the parking meters, and there are the traffic lights, there are the cars softwares, and they are connectivity through a WAN live Wi-Fi or over the any radio channels, and connected with some kind of application which are using some kind of APIs, and with the database and sharing that data into the cloud or the application. And you are able to fetch the details via applications. Okay. So coming to the next, what is the IoT ecosystem? IoT ecosystem like is the sensors in the IoT devices, the devices connectivity, and application in the smart devices, and application and processing on the cloud. What basically like what data you are like sharing, and it is processing over the cloud and communicating all over the world. Okay. And data analytics and security. So basically, we are here to talk about the what is the IoT device and the security we are going to implement and how we are going to exploit these IoT devices. Okay, so basically IoT pen testing approaches, like what are we are going to follow? Is there any methodology and any kind of approach we are going to follow? So, like if we talk about the IoT pen testing, as the same, we are talking about the infra, web applications pen testing, and mobile application pen testing. Like we are limited to the word of the application or particular limitations of IPs. So if we talk about the IoT devices or IoT system as well, they are installed in the company or any industry, like any water filtering devices or some kind of pipelines connectivity. So if we talk about that, like every device and every infrastructure which is connected to like that devices, like everything should be covered in the IoT system as well as its complete infrastructure. And what are the approaches we are going to follow? There's some kind of black box testing. Black box, if you heard about the web application VAPT, so like web application black box testing is like you have no prior knowledge what are the IoT devices are, what they are actually doing, what are the workings there, and like anything like nothing about that. And in the gray box, like you have aware about the what are the APIs you are using and what are the testing methods, yeah, like what are the applications you are running on, and application what are the application stack, and what are the another library you are using. And coming to the white box testing, white box assessment are testers are given full access of code, network diagrams, and architecture diagrams, like from where the data is flowing, from where like and is connecting to the network, and like a complete sharing functionality of the IoT environment. Okay. So, and coming to the next, IoT pen testing. If we talk about the IoT pen testing, there are two majorly covers like why hardware and why software. If we talk about the hardware mostly hardware should like having a functionality of like some kind of connectivity with the applications, like using kernel devices, kernel and firmware, some kind of root access, and grabbing content of flash memory, flashing the hardware memory, side channel attacks, and reverse engineering PC boards. What are the PCB boards? PCB boards are the mostly the SOCs which are like into the like PLC devices, and what are this and why software? This is the web and mobile app vulnerabilities. Most of the configuration issues are happen over there, and buffer overflow, fuzzing attacks, data leakage, insecure authentication, and unprotected APIs communication. Okay. So what are the IoT pen testing methodology? What we are going to follow, like what is the IoT ecosystem, understanding the IoT ecosystem, and set up the environment of IoT pen testing, like what are the devices and what we are going to do, like what are the tools we are going to follow, and like what are the steps we are going to take, like complete ecosystem or complete lab setup of your IoT pen testing, some kind of, and then functional testing, then some kind of open source intelligence gathering, like if you talk about the like some kind of uh, any access point you are using, an access point or any router you are using. So like mostly we can get information about that, like vendor website, what are the currently firmware they are using and what are the version they are using right now. And so like this kind of open source intelligence we can cover in this. So and then capture and analysis of data communication. Data communication like capture analysis, like connectivity over the network. If application is communicating with the other network, so like what are the data it transmitting, like what are the network packets it is transmitting, and which type of data it is transmitting to other source. Okay, so what is the vulnerability and penetration testing of mobile and controlled application, VAPT of web and mobile and other controlled application, and it can be .NET applications, window based application, and iOS. Testing cloud API and web services, like what are the APIs are used and what are the other web services are used. Some uses the microservices over the web and some completely based on the API. So testing of embedded hardware also. Okay, so we know about the OWASP top 10. We heard about in the web applications, like these common vulnerabilities are like these top 10 vulnerabilities are over there, and we have to follow like 10 test particular test, and we have to map all those vulnerability into that. Okay, so for the IoT was having like top 10. One is weak, easily guessable or hard coded passwords. Like if we talk about the firmware, some kind of like hard-coded passwords are embedded in the firmware. And if we talk about the router, if you are opening a router homepage, so like basically mostly are using by default password admin and password. So these are the kind of weak and easily guessable things. Okay. Insecure network services, like if we talk about the insecure network services, they are not communicating over the SSL certificate. Like they are not using any type of SSL certificate, and they are communicating with the unencrypted traffic, which can be easily decryptable or easily can be seen by the some kind of network sniffers. Okay, insecure ecosystem interfaces, like if there are any uh, physical code is open and it is open, like openly visible to all, anybody can like enter into the like just override the application, override the firmware, or some kind of backdooring after taking the firmware and binding with some kind of backdoor and just uploading it. So some kind of insecure ecosystem interface. Lack of secure update mechanism, like if the firmware are like if we talk about the like currently we are growing into the like IoT field, and we are using some kind of like filtration techniques in the water pipelines. So like there are the firmware which are we are using, and they are like update since we are coming on, and we are not able to update. We are not proper, like companies are not proper focusing on that for the security point of view. Just the their main goal is to keep functionality running. Okay. If you have seen like recently heard about the news that colonial pipeline attack, so that was the like some kind of phishing attack and the some kind of unprotected and update mechanism failure. Okay, so some kind of tick over happened there. That why the exploitation happen into the firmware, and they are able to attack with the ransomware. Okay, so insufficient privacy protection, insecure data transfer and storage. Like insecure data transfer and storage, like they are keeping any data in their local memory. We can easily degradable or some kind of unprotected, unsecure data. Like they are not following any mechanism, any encryption mechanism in their devices. Lack of device management, like proper take care of the devices. Insecure default setting, like they're the everything, like they are using the default configurations with our default username and passwords. Okay. So, and lack of physical hardware. Lack of physical hardware means like any unprotected open physical ports, any like URT ports, some kind of these things. Okay, we will cover in the URT ports and we'll later. So, talking about the IoT firmware. Firmware is a kind of software that is written to the hardware devices. As you can see, like in your computer, if you're having a firmware, running firmware, and you are able to, you're able, like, there's some kind of low-level programming code that enable the software access and to the hardware functions. Okay, like you are able to use your physical code into with your software package. Okay, like firmware is comprised of a bootloader, kernel, file system, and various other resources. There are different type of firmware built upon embedded Linux, embedded Windows systems, and Windows IoT core. These are kind of like recently they are using uh, some update mechanism, like you have also seen some kind of AWS IoT, and there are other mechanisms they are also following. Example of embedded devices that run firmware are smartphone, mostly, traffic lights, connected vehicles, some type of computers, PLC. PLC are the like, programmable logic controllers, CCTV cameras, drones, cable setup boxes, etc. Okay. What is the like firmware analysis methodology? Like what we are going to follow in the firmware methodology? Like first you have to grab the firmware. Like if you are talking about the some kind of TP-Link router, so let's just go on the vendor side and just grab the firmware. Just download the firmware driver, firmware. So like you can use as for the practice purpose point of view. Okay, for the analyzing firmware, like you have to like analyze like what type of code they are running. Like you can use some kind of open source information, like open source intelligence information, and like with some of tools you can analyzing file system contents and emulating firmware for the dynamic analysis. And like you can bind your firmware, like you can just combine your firmware and upload and see the next functionality if you are changing anything. Okay, getting started with ARM and MIPS. What are the ARMs? Like everyone know, like limited resource, like based on the reduced instruction set computing, and MIPS like millions instruction per second. Okay, so like we are exploiting that functionality also. If we talk about like there was the Iran attack in which the Iran nuclear attack. Uh, that was a virus that happened in the nuclear plant in Iran, which affected the some of the ARM, the architecture, and it changed the functionality and overwritten the functionality of that PLC device, and they are able to like they are able to increase the cycle of their nuclear power, and they are able to destroy that nuclear plant. So these kind of like security controls we have to follow, like getting we don't have to like be hard coded. It should be hard coded, and it should be physically protected, and it should not be reverse engineered, and it should be protected somewhere. So analyzing and exploiting firmware. What are the basic controlling like test cases are the passwords, some kind of passwords we are using, some kind of passwords we are basically hard-coded passwords we are they are in the firmware, and API tokens, some kind of API endpoint URLs are also in the firmware, vulnerable services, some kind of backdoor accounts, configuration files, some kind of source code. Like if they are not using like ops, they are not obfuscating their source code, so it will be problematic. Like when they are like exposing their source code. If any attacker able to access into the system, and it is able to see the source code and analyze what is the currently configuration going on over their network, over their SCADA network and IoT network. Okay, some kind of private keys, it can be API keys, and which are stored in the firmware, and how their data is stored, like some kind of their like any database they are using. So like they have the complete knowledge of like what is going on there. Okay, some kind of firmware analysis tools. They are mostly firmware analysis toolkit. Will mostly be completed as FAT. It is based on the Firmidine with some changes, and Binwalk, Ember, Firmidine also tried. Firmwalker. Like you can use these type of tools to unzip the firmware and analysis accordingly. Okay. Coming on the web applications, like web applications which are used to control the IoT devices, and they are embedded with the web servers, database servers, and some other microservices, and which are separating each server is due to performance and availability reasons. Application why we are using the web applications IoT for better connectivity and better database management and better communicating over the network. Okay. And user applications are of an IoT structure. They help users in monitoring control IoT devices from remote locations. Okay. So there are the two type of models which are using in the applications and the web application. One is hybrid model, and second one is embedded devices. Hybrid model is a mix of the vendor or manufacturer providing software as a service, web application, and also connecting the web application running off the firmware. Like they are directly communicating to the firmware, and for the better communication and better use of services. And embedded devices web application are as mentioned running internally of the devices. If we talk about the internally, just you can take an example of the router. Like they are their web application you can access via their IP, and you are able to easily access the complete web application, and you are able to change the password. So these are kind of embedded devices web applications. So exploitation of the web applications, if we talk about the exploitation, so web application penetration testing methodology is there are the different framework. You can use PTES and OWASP top 10. Okay, and like mostly OWASP top 10 testing methodology provide a number of examples for you and as well as tool references and the users. And the most popular test cases in the IoT web application are like client-side injection. Client-side injection, like mostly the web application is just built and just uploaded and just running the functionality of their IoT devices and between their IoT devices and other server. But they have no security controls, which can load, like uh, which can like different type of attacks, which can lead to different type of attack. One is the client-side injection, and one is IDOR, insecure direct object references, and insecure authentication, sensitive data leakage, and business logic flaw, cross-site scripting forgery, cross-site scripting, and API testing. For the API testing, mostly most of the problems are like IDOR. IDOR is like sometimes of if you are aware about the web pen testing, some kind of ID is equal to 1. If you are seeing the URL and it is saying ID is equal to 1, and you are able to change into 2, and and then you are entering and refreshing the application, and you are saying that I am able to see the content of the second ID. Okay, which is the second ID. Like it is not controllable easily. So like it is exposing some kind of sensitive information. So it leads to IDOR. Okay, and also the sensitive data leakage. Sensitive data leakage can be some kind of server information and some kind of database information, some kind of web application functionality, and some kind of source code also. For the web application testing tools, there are the many tools which are used. Most of the popular are the PubSuite, and second is OWASP Chap, Nikto, SQL Map for the database, Papilizer for identifying the technologies, Cookie editor is for the cookie if you are editing any kind of cookie. Fab for the exploiting, Metasploit for the exploiting, Hashcat and John the Ripper to crack the password, Postman for the API pen testing and seeing the response in your browser. Okay. Okay, for the mobile applications, if we talk about the mobile applications, like everybody can download the application from the Android store and iOS store. Just just install the device and pair with their IoT device. It can be smart bulb, it can be Bluetooth device, or some kind of it can be anything, some kind of Alexa, Google Cloud, or something. It can be anything. So, like mostly applications are connecting with the mobile applications, and it can be Android, iOS, or Windows Phone devices, and also it can be hybrid device, hybrid or native applications. So, hybrid applications utilize both web technologies like HTML, and it can run over the website. Like if you are opening an application and they are following a URL, and it is opening in your application, and they are hardware accessing through the plugins like your GPS, your Bluetooth. Okay. And native applications, they are perfectly written into the one language, and they are easily like using SDKs. They are easily accessible the camera, Bluetooth, and GPS, like other hardware things in your phone. So for the mobile application testing methodology, like what we should what we have to follow, like if you are using some kind of Google Alexa, or some kind of uh, Alexa smart home hub, any type of hub. So like just gather the that IoT mobile application, and you can decompile Android application using the APK tool or some kind of mob SF, and also you can decrypt iOS application via the different tools. MobSF, using MobSF for static analysis. Static analysis is like the reviewing the source code of the mobile application, and like how it is communicating with the your devices, like your server and your the IoT devices. Okay. Analyzing Android data storage, like is there any sensitive information they are storing in the local storage, and in plain text information or something, and performing dynamic analysis testing via using some kind of Android emulator, and like you can break easily the functionality, like you can change the request and forward it to the server and see like what they are responding to you. Okay. So for the mobile application vulnerabilities, mostly this is the MASVS is like it is a framework, and also the following the OWASP mobile testing guidelines framework, and checklist point, like it having the many vulnerabilities, and we are just I have note down the some most common vulnerabilities within the IoT space. Okay, some kind of reverse engineering the mobile app, dumping source code of the mobile app, insecure authentication and authorization checks, business and logic flaw, side channel data leakage, runtime manipulation attacks, insecure network communication, and outdated third-party libraries and SDKs. So like why we are like covering these all? Okay, so like if I am communicating with my mobile application with my IoT device, and it is communicating over a local Wi-Fi network, and like I am able to see what type of information it is sharing, like what type of connectivity it is happening within the IoT device and my mobile application. Like we can check, like, or I can manipulate that request. Okay. So like is there any sensitive information they are sharing with the cloud, or any or it is embedded with the source code of the application. Okay. So these type of vulnerabilities we are going to check in the mobile application. And for the mobile application exploitation tools, like you can use MobSF. MobSF is used for the static analysis and as well as dynamic analysis. Genymotion or any emulator, Android emulator, you can use Android debug bridge, sorry, and Frida and objection for bypassing the SSL. Okay. APK tool you can use Wireshark, you can use Burpsuit for the Burpsuit or ORCheck proxy tool, Hashcat, as said, like it can be used for the password cracking, Hopper or Gitra for the reverse engineering of the application. Okay, Xcode for iOS and Android Studio for the Android application. Okay. So coming to the hardware exploitation methodology, like hardware exploitation. If we talk about the hardware exploitation, like I am having an Arduino board, Arduino or Raspberry Pi, and we are having an opening port between like some kind of USB port, HDMI ports, or kind of any Bluetooth connectivity. So like if I am going to exploit that, or any PLC device, if we are going to exploit that, so what is the methodology we are going to follow? Okay. So, like first, we are going to information gathering and recon, like which type of device it is and what it is using. Like you can use some open source intelligence also, or some you can use like you can easily see that particular device or particular serial number of that device, and you can easily search on the internet, like what is the architecture and what are the like functionality it is having. Okay, external and internal analysis of the device, like what is the functionality and what is having it is what kind of functionality it can perform. Like if in a Raspberry Pi you can upload a different type of Linux, Windows, and other softwares, and as same as if you are having a PCB boards in if we talk about the IoT devices which are generally planted in the industries and in the industry sector, like motion sensors, if we talk about the smoke sensors, and some kind of CCTV cameras. So like if we are going to scan that completely network, and we are able to get that some kind of information, like what type of device it is, and what are the versions, and what are the systems they are running on, and what are the web application sorry, what are the like vulnerable service they are running on. Okay, identify communication interfaces. It can be communication interfaces can be physical or like logical communication interfaces. Like you can, if you are plugging your pen drive into your PC, so it is kind of like physical interface. And logical interface, like you can see like some kind of connectivity with your Wi-Fi, or some kind of open ports and logical open ports inside the devices, like or they are running on. Okay, so acquiring data using hardware communication techniques, like have you seen like every in movies, like you have seen, just we have just plug in the pen drive and just gather all the information of the machine. So some kind of that trick, if you heard about the USB rubber ducky, so like you can easily make one with that is some kind of programmable board coming on at sorry that is a tiny from the Arduino. Like just you can program your like what you are want, like so you have to crack the window password, or some kind of mobile application, or some kind of backdooring, like you can easily use that. So like gathering information from that physical device, like physical techniques, and also the software exploitation using hardware exploitation methods. Hardware exploitation, like if there are, as the example I have already uh, told you, like for the rubber ducky, and there are many other information, like uh, if we talk about the radio controls and Bluetooth functionality, we are currently now using Bluetooth low level energy and BLE, which called BLE, and which are used in the currently in your headsets and Bluetooth speakers and many other devices, as well as your health band. Okay, and backdooring. So these are the kind of mostly methodology we are going to follow, like how we are starting from information gathering to backdooring. Okay. Backdooring is optional because like if we are able to access and able to backdoor the firmware backdooring, like if you are able to backdooring the firmware and rebuild it and upload it to the hardware, upload it to the PCB board, and then we are able to get the access into the network. Okay. So IoT hardware pen testing, like there is the internal communication protocols, like one is the UART, and one is I2C and SPI. These are the communication protocols which are using in the in the your PLC devices and your the architectures. Okay. Some kind of open ports, it can be physical or logical. GTAG debugging. Okay. Exacting firmware from EEPROM or flash memory and tempering the hardware or just manipulating their data. Okay. So for the hardware point of view, like we are going to use different type of tools, some kind of like dumping flash memory. Dumping flash memory you can use via TTL and directly communicating with the PCB board, and like you can easily download the firmware, or you can easily flash the firmware. Okay. And open UART ports. Open, these are the physical UART ports. Like you are just plug in the the female or male headers into that, and just able to get informations according to your choice. Okay. One is the JTAG exploitation. Okay. And open UART ports, like you can see. Coming to the radio communication exploitation, what we are going to in the radio, like some kind of if you are using a TV, and you are having your remote, and it is some kind of information like sharing with your remote within a TV through the IR sensors. Okay. Some kind of light, that is light connect IR light connected into the your remote, and is communicating into the TV. Yeah. So, as well as in the companies, like many of the process are happening over the radio communications. Like if we talk about the satellite phones and some kind of radio control devices like crane or machines, uh, and and etc. etc. That can be a lot of things. Okay. Exploitation of communication protocols. That is one is BLE, that is Bluetooth Low Level Energy, and Zigbee, LoRa, and 6LoWPAN. These both are the sorry. These devices are like low range Wi-Fi network, and also the like low energy ranges, and this is the IPv6 pan area network. Okay. And what are the sniffing radio packets via SDR, like we can capture the packet and easily download that packet, or download, or you can see like you can use that packet or later, or you can modify that packet and play a replay attacks. Like if you are there is a virtual environment. If I told you about virtual environment, like some kind of replaying attack, if like train is moving from here and there, we are able to, and we are able to like modifying that attack and replaying that particular from movements from train from here to there. Okay. So like these are called the replay attacks. Like we are able to call one by one, or replay that call again and again. So some kind of exploitation of BLE 4.0 communication, like Bluetooth Low Level Energy. That is this is the Wireshark uh, capture snapshot, which is used in this and like you can see easily the like command, and like you can easily see the communication which is happening, which is going on there. And this is the tool which is communicating with the Bluetooth devices. Okay, and it is this is the GAT tool which can override the override the your transmission, or override your protocols. Okay, and this is the USRP, a software-defined radio protocol, which uh, record the traffic, or which record the radio traffic, and it can be used to jam that network also, and it can be used for replay chain attacks also. Okay, like you can see the perfect band over their radio bands, and you are able to modify that band and change the request accordingly. So mostly IoT radio security tools are the one is GAT tool, HCI tool, one is GNU radio, and Killer B. Mostly IoT hardware. If we talk about the IoT hardware tools, that is one is Hack RF. This is more like fancy one, or you can say most popular one right now. And but every tool having a different functionality right here. One is for the Overtooth and TTL USB converter. One is JTAG calculator, Zigbee sniffer,
Audible?
and bus pirate.
Excuse me, sir.
Yeah, hello.
Am I audible?
Yes.
Actually, sir, we have entered the end minutes of our session. So
Okay.
everyone is requested to join from the another link.
Okay. Okay.
In chat box also, the link is provided, and it will be provided in the group also. Okay.
Okay. Okay.
So you all are requested to leave this meeting and join the another meeting. The link will be provided to you soon.
Okay. For sure.